turn on the notification bell so you won't miss any of our upcoming DIY ideas. Here are the bolt and nut I prepared. I'll be using this bolt and nut to build a connection to the soldering tip, a simple yet crucial part that holds everything firmly in place and ensures stable performance during use. I'll carefully grind down one of the bolts to slim it down. This will help it fit perfectly with the soldering tip and ensure a snug, secure connection. The tip is now nicely ground down, slim enough and ready to go. Now I'll mount it to hold the back of this nail clipper to start forming our mini welding setup. With the bolt securely in place, it's time to move on to the wiring. The heart of this DIY mini welder. I'll be using two flexible wires, one for positive and one for negative. First, I'll strip the ends of each wire. Then connect them carefully. One end will be attached to the metal clip of the nail clipper. You can adjust the temperature yourself by changing the wiring or adding resistor. It's super flexible for small welding tasks. Since this is a mini welding machine, thick electrical wires aren't necessary. I'll use this type of wire and it will work just fine. To make it easy to hold and use, I'm adding a handle. The simple cylindrical piece will work perfectly for the job. This setup will allow electric current to flow through the tip, just like in a real soldering iron. To keep everything firmly in place, I'll use zip ties to attach both the wires and the nail clipper to the wooden handle. It's a quick, clean solution that holds everything tightly without the need for screws or glue. So, what's special about this welding machine? First of all, it's super cost effective. No need to spend money on an expensive machine. Just repurpose items you already have at home. It's cheap and fun, just the way a DIY project should be. To finish up this part, I'll use electrical tape to tightly secure the components and insulate the exposed wires. A simple but important step. Wrapping with electrical tape might seem simple, but it's a key step. It locks everything in place and provides crucial insulation for safe use. A tight, clean wrap makes the whole setup sturdier and safer. This component is called a terminal block. It's used to join electrical wires together firmly, while keeping everything neat and insulated. In this setup, the terminal block will serve as a connector between the bolt and soldering tip, making the link both secure and easy to adjust if needed. I've got quite a few old batteries lying around, perfect for experimenting with this mini welding setup. Instead of throwing it away, I'm going to repurpose the inner core of the battery and turn it into a soldering tip, a clever way to give new life to old materials. I'll carefully extract the inner core from one of these old batteries. This core is usually made from conductive metal, and its size makes it perfect for precise soldering tasks. When doing this, it's important to be cautious, avoid touching any leaky material, and always work in a well-ventilated area. Once the casing is removed, I'll trim and shape the core to fit our terminal block connection. It's a great way to recycle and repurpose parts that would otherwise go to waste. Next, I'll grind the battery core to shape it into a fine soldering tip. This will help it heat up evenly and work more precisely. Now that it's been ground in the right shape, the core fits snugly into the terminal block. And just like that, we've turned it into a working soldering tip. To complete the wiring, I'll attach an alligator clip to the other end. It makes the connection quick, secure, and easy to attach when needed. I'll add another wire to connect from a negative terminal. This will complete the circuit and allow current to flow properly to the soldering tip. For this wire, I'll attach alligator clips to both ends. That way, it's easy to connect and disconnect from both the power source and the device. The alligator clips act as flexible terminals. They grip tightly onto wires, battery terminals, or metal parts, making it easy to test and adjust connections during prototyping. Plus, they save time by eliminating the need for permanent joints. For the power source, I'll be using a standard motorcycle battery. It's a 12V lead acid battery, powerful enough to heat up the soldering tip and stable for small electronics work. This type of battery is easy to find, rechargeable, and delivers consistent current, which makes it perfect for our DIY soldering project. Now it's time to put our DIY soldering tool to test. I'll begin by trying to solder onto this razor blade, which is thin and metallic, making it a good challenge tool. As I bring the soldering tip to the joint, the solder begins to melt and flow smoothly onto the razor blade and the strip wire. The tin spreads evenly, bonding the wire to the metal surface in a single, shiny solder joint. After just a few seconds, it cools and solidifies, creating a strong, clean connection between the wire and the razor blade. After soldering the two razor blades together, the joint feels surprisingly strong. Even when applying pressure or flexing slightly, the blades stay firmly connected without any signs of separation. The solder has bonded well to the thin metal surfaces, creating a solid bridge between them. And that's it. From a simple nail clipper, a few wires, and an old battery, we successfully built a functional mini soldering tool. The joints came out solid, the response is fast, and it handles small tasks surprisingly well. It's a great example of how creativity and basic materials can come together to solve real problems. If you enjoyed this project, don't forget to like, subscribe, and turn on the notification bell so you won't miss any upcoming DIY ideas. Thanks for watching, and see you in the next video.